So what you saw there were two distinct devices, but what was really important was what you saw was a full simulation running on both systems, and they're perfectly synchronized, even a fairly complex system. That wasn't screen sharing, it's actually a shared computation. That's what really Croquet provides underneath the system, is an ability to share any kind of information, any kind of idea. In fact, the whole system I'm working in is a collaborative framework. And there's a number of applications here. As an example, another example is even web pages are perfectly shareable. So this is Apple's web page, and as I go through this, I can actually scroll through it and you see exactly what I see as I do it, or I can jump to another web page, a link, and you'll see me jump to that as well. But beyond that, we actually can do any kind of application. Just think about this as underneath this is a Croquet framework, but our goal is to enable people to collaborate and communicate in a way that's just not possible today. So as I draw on the right whiteboard on the right-hand side, you see me interacting with that totally seamlessly. In fact, I can take the same application and jump it onto a phone or any other device. Going beyond that, shared simulations. This is a good example of that, and even medical applications. But our focus is enabling people to share these complex ideas, being able to share any kind of document, for example. In this case, I'm able to scroll through this, and you would actually see, as I scroll through it, you'd see exactly what I see. We're literally on the same page. We like to say, what you see is what I see what you do as you do it. And this is a really key concept. The way we see 5G evolving, in fact, is it's all about this, a shared reality. When we think about augmented reality, we think of it as making the virtual as live and engaging as the physical. So when we think about what 5G brings to the table, it's this amazingly low latency interaction that allows us to know that what I'm seeing and what you're seeing is exactly the same thing. We're in fact already working with a number of telcos, been working with Verizon, Orange, Telefonica, and we've already integrated our reflector technology, which is the thing that drives this, onto their platforms, so that we're beginning to see just how good and important 5G is going to be. But think about this, when you're engaging with somebody and you're doing some kind of complex interaction, you're looking at 5 to 15 millisecond latencies. When you're at that low level, when you're that fast, you can actually play instruments together. This is a really big deal. 5G isn't just, it's really important to think about the broad band of information you're going to get, but the really more important thing is extraordinarily low latencies that are really going to transform what we think about as a physical interaction. Thank you.
Thanks so much, David. So question here from the audience. Why is Croquet important for 5G powered AR applications?
One of the things you can't do with AR is when you do a render, you can't do the render remote because that creates too much of a latency background. So what you have to be able to do is, you're looking at trying to track the head at 60 to 120 hertz. So you have to render locally. But the simulations that are being run have to be computed locally as well to make sure that they keep up. So the real value of AR, the real value of AR and 5G together is that low latency, so that you're actually, as I said, you're making that the physical world and the virtual world absolutely seamless. That you'll actually be able to see the overlays of very complex shared information on the real world. The only way that's going to work is with 5G. That's the only system that's going to be fast enough with the lowest latency so that I know that what you're looking at is exactly what I'm looking at.
Great. Thanks so much, David.